Perfect. Okay, thanks a lot for all for joining us today and for this session, and where we are gonna learn together Terraform. So this session is has been organized by Brainboard's team. So yes, just a brief presentation about myself. I'm Shafiq, the founder of Brainboard, and I'm an engineer. I've been working in the industry for the last 15 years, and I started Brainboard 3 years ago, and I was a former CTO. So my background is mainly in the infrastructure and building infrastructures. So that's why we are organizing today the training to share all the knowledge with the community. This is me, and briefly, Brainboard, what it is, it's a solution to visually build and manage cloud infrastructures. So it allows you to visually design what you want to do in terms of target infrastructure, and it will generate the Terraform code and allows you to deploy it. This is briefly about Brainboard. So, and the first, to start with the training, we set an objective at Brainboard. So our objective today is to learn how to manage cloud infrastructures with Terraform. So no theory, which means that we will be learning how to manage the infrastructures and not just like learning how Terraform theoretically works. So, and we'll be doing like, the goal, two things: to understand clearly how Terraform works and how you can use it to manage real infrastructure at your company. So, and for the training, I will be using Brainboard. So just because it generates the code automatically, so it saves time for me for the explanations. And also it helps me explain different things in the same place. So feel free to use either your VS Code editor or sign up to Brainboard if you want to follow the training hands-on way. So feel free. Tarek and Stefan, maybe they will share the link on how to sign up. And so this is what we are going to see today together. So we're going to learn how Terraform works. This is like a broad topic, but we're going to be more specific on the mechanics of how Terraform works. And we'll be taking questions regularly, so please feel free to ask your questions in the chat. Stefan and Tak will be taking the questions, and we'll be doing breaks to answer your questions. So feel free to ask your questions. So we are like more than 400 people in the stream, so it's going to be difficult to answer live. We're going to answer them in break. So then we're going to see the syntax that Terraform uses, which is HCL. Then we will be reviewing the configuration, what you need to configure to be able to work with Terraform in a clear way, in a production-ready way. So, and then we zoom on the resources, data sources, modules, input, functions. And by the end of the training, we're going to do a scenario or use cases. It's going to be small scenarios because we'll be providing all our sessions to zoom on different scenarios, like the one we did a month ago, which was an implementation of Kubernetes on AWS. And we'll be talking about how to handle post-provisioning actions. So let's get started. So now, before talking about Terraform, let's take a few minutes and talk about infrastructure as code in general. So simply put, infrastructure as code is applying the code principles into the infrastructure. So which means we want to take advantage of managing the infrastructure in an efficient way and taking advantage of how the code works. So we want to apply these principles into the infrastructure, which means we want versioning, we want testing, we want code review, automatic deployment, change management, and so on. And so this makes a lot of sense because the flexibility we have in using the code it allows us to manage the infrastructure in much more secure and robust way. So this is in terms of infrastructure as code. So now let's see how it fits the infrastructure as code within your workflow. So and how we work. There are two lives when you work with code. There are life before having the code and life after having the code. So before having the code, life is before having the code. So you need to design first what you want to do. Then you need to write down the Terraform code for it. Then you need to test it, review it. You need to write documentation with it. And you need to validate it. Like these are roughly the steps, but you can add more or less, add or remove steps. And once you have the code, you will be deployed in like a push button deployment solution into the cloud. So and all the optimization that we see in the industry are after having the code. So like Jenkins, GitLab CI, Azure DevOps, GitHub Actions, and so on. All these, you use them once you have the code. But the biggest part is before having the code. So, and that's why, the complete workflow of managing infrastructure should include both steps. Now let's zoom on how, jump in on how Terraform works and its mechanics. So Terraform is the first thing when we think about Terraform, it's like a project, it's an open source, it's a lot of things, but down the line, what we use is a binary. So, and this binary, you either download it, it's a zip binary, and install it on your machine and use it, or you can download the Docker image that contains the binary and you can use it. And there are official Docker images distributed by HashiCorp. Once you install the binary, so you're going to use it as a CLI. It's going to be Terraform with action, Terraform apply, Terraform init, Terraform destroy, Terraform do something. And this is how it works. So now Terraform, to be able to work with Terraform, you need to write the HCL code. So this is what we call it, write Terraform code. It's an HCL, HashiCorp code. And using Terraform is simply means writing HCL code. You can also write JSON code, but it's highly advised to work with HCL. And we're going to zoom today on how you write HCL code and how you manage the infrastructures that way. And how it works. This is like state language, which means you need to describe the final cloud architecture that you want to achieve, not the how-to. So the how-to will be managed by Terraform. So, and you say, I want to deploy, I want to have a VPC with subnets and virtual machines inside it. So you describe it, and Terraform will create this target infrastructure by getting in touch with the API, contacting the cloud providers, and sending them the request to provision the infrastructure. So which means Terraform is a wrapper on top of the cloud provider's APIs. So this is very interesting and important point, which means that instead of using directly the APIs that the cloud providers offer, we use Terraform that override all this and also handles the changes in the API, the versions, addition of new resources, deprecation of other resources, and so on. This is like a wrapper of the cloud resources. That's why it's important to understand two aspects. That in terms of open source project, you have the link here, HashiCorp Terraform, that will be compiled into the binary that you use. And on the other hand, you will be you have the open source project which are HashiCorp/Terraform and the name provider and the name of the provider. These cloud provider repos provide the resources that will be used within Terraform. So this is like, and we put the links here that Tarek will share with you. So you can check both of them, but keep like this in mind, because sometimes you hit issues like, and you need to understand if the issue is with Terraform itself, the binary, then you need to check the source code of the GitHub repo of Terraform, and you create an issue or understand how it works. Or you have a problem with the provider you use. It could be Azure, it could be AWS, it could be any other provider, and you need to understand that the problem is with the provider, and you go check it there. So this is like the first information that you need to understand about Terraform. We are going to zoom now. So using Terraform means you will be doing Terraform action. Terraform init, Terraform apply, destroy, validate, and so on. And which means you will be asking Terraform to do some actions on your behalf to your cloud provider. And to be able to do that, you need to give information to Terraform to like what you want to do. And this is important aspects. We're going to see here how the mechanics works. So before talking about that, keep in mind that whatever you do, whatever the Terraform code you write, you will be designing an architecture. Maybe you design it in your mind, maybe in a white paper, maybe in a drawing tool, whatever. You will be designing architecture, and you're going to write down this architecture into code and ask Terraform to apply it. So to understand how it works, first, you have the configuration files. These configuration files are the files that you write, the Terraform files that you write. It's called configuration files because it contains the configuration of the resources that you are going to create. These configuration files, it can be Terraform files like .tf extensions, or it can be saved plans. And we will see later about the saved plans. Like you can do a plan, save it, and say, okay, this is the configuration that I want to deploy to create in the target cloud provider. So the relationship between the configuration files and the cloud provider is that the configuration files is the state that you want to achieve at the target cloud provider. And now, so when you do when you run, for example, a Terraform plan, it's going to be Terraform. We're going to do pre-flight checks. So it's going to check if it is able to execute what you asked or not. So, and to do that, it will be using a Terraform state file, state, to track every changes and all what will be doing on the infrastructure. So, and this state file, you have two situations. Either you do not have the state file, so Terraform understand that it will create all the resources, or if you have the state already a state file, Terraform will compare the changes. So we'll compare what you asked Terraform to do and what is already deployed, already existing at the target cloud provider. Then once all this compilation is done, so before creating the infrastructure, Terraform will refresh the state. This is what is called refresh the state, which means it will pull the information from the cloud provider to be able to have the latest information from the cloud provider and compare it to the changes, and to be able to know what to do. And to know what to do, you have there are 4 types of actions. It will be either creation of the resource doesn't exist, and it will be created. It will be also destroy, like a resource exists in the Terraform state file, but it doesn't exist in the configuration file. So in that case, it will be destroyed. it will be destroy and recreate if Terraform cannot update, like hot update the information of the resource, because the cloud provider doesn't allow it. So it will destroy the resource and create a new one. And you need to understand and be careful about these actions. In all cases, Terraform warns you about any action that you will do. And the last action is going to be just update. Like you want to update an information that about the resources that already exist. This is how it works. And now, like once the Terraform Terraform creates and does the actions on the cloud provider, it will write all this information, the tracking, in the state again. So you will be having an updated state. So these interactions are important to understand, to be able also to understand when you have problems and how things work. And as you noticed, when I talk, I also have in mind production in mind. That's why I talk about if you want to debug it, or if you want to if you want to debug it, or if you want to understand when things go wrong, because again, this is hands-on training. Like you will be managing infrastructure by understanding this training. So now that we understand the mechanics, so let's move now to understand how can we write something that Terraform understands and that will be creating the architecture that we want. So Terraform uses HCL, which is a HashiCorp language. And this HCL is like, it looks like YAML, but it's not YAML. It's a mixture with YAML and JSON, because like you have the definition, it looks like YAML and JSON. And the supported files are, when you work with Terraform, are .tf and .tf.json. One important information is that all the files that will be parsed will be combined in one document, single document. So this is a very important information, and we understand later when we talk about dependency. Like we need to understand this because it helps us understand how the dependencies are managed and how we can organize them. So yes, and HCL. So I do the comparison between what you write in HCL and how Terraform works. And when you write HCL, you are always working within a module. So keep that in mind. Even if you don't know modules now, it will come later. We will see it later. You will be working in the module, and the default module that you will be working on is the root module. So yes, and everything in the HCL language is a block. So we will be talking about a block everywhere. Like when we define resources, we talk about the block. When we define data sources, we talk about the block. Variables are block, modules are block, and we're going to see them all together. So this is in terms of the block, and the definition of the block is pretty simple. So you write the type of the block. It could be resource, it could be data, it could be Terraform, it could be anything, any object that Terraform supports. And we're going to see more examples on it. And the block could have one or more labels. It could have one or more labels, and it could have no labels, just the block type. And inside the block, you will be defining the parameters that you want the cloud provider to implement within this resource. So, and how we write it, it's an identifier and an expression. Identifier is like when I'm talking about the cloud providers, is the parameters that are supported by the cloud provider. For example, when we see, let me show you an example. It's better that. So here I use a Brainboard, and just to explain, I was talking about the resources and cloud providers. Here is the list of all the resources of Terraform that you find at, for example, the cloud provider AWS. If you want to understand of Azure, for those who are following us on Brainboard, so you can switch into all the resources and see them. And I'm gonna clone an architecture, for example, a simple one here to show you. So when this is the Terraform code, and this is how the definition of resource is done. Like, you have the resource, you have the name of the resource. This is the first label. This is the resource type, the first label. The second label is the name of the resource, and inside it contains all the parameters all parameters that you need to fill to be able to use to provision your infrastructure. So here is this is like an example where I have the resource, the block with two parameters, with two labels. I can show you another one. For example, if we look into variables, so the variables have just one label. You just specify the block type is variable, and then you give it a name with the configuration. And I give you an example of only one only the block type, which is, for example, Terraform, and doesn't have labels. It's just the block, and inside you can define all the information that you want. An important information when you write Terraform code, that the identifiers that are letters, digits, underscores, and hyphens, and the first character must not be a digit. So this is very important information, because if you do it, you will be having errors. Sometimes errors are not obvious. Sometimes are really obvious. Sometimes not. So be careful to respect this rule. And also about the styling, I would say don't care a lot about the styling. Just write the code and use the Terraform FMT that will write the clean code after. So, for example, here this is code generated by Brainboard, but Terraform works the same because we use Terraform behind the scenes. So it will create a code which is clean and that represent exactly the spacing and the tabs that are nice to read and easily understandable and especially maintainable. So this is in terms of the syntax. So now, and it's also good practice to include in your CI, if you have continuous deployment, it's a good practice to include maybe linter. There is a good project called TF-lint that you can put it part of your infrastructure deployment pipelines. So if you want like to have commits that contains clean code that the other team can maintain. So this is the syntax. Now we're gonna see the configuration. So what do you need to configure to be able to use Terraform in a production way? So, and keep in mind that I'm not just talking about using the binary and like in your laptop and with the binary you are gonna provision infrastructure. I'm talking more broadly on how to manage infrastructure in a good way to maintain production. So that's why there are some information and elements that we need to take into consideration, and some aspects we need to plan them before starting the working on the infrastructure. So you have three types of configuration in general. The first one is like you have the Terraform configuration, which means like if you want to use a specific version of Terraform, or if you want to use some environment variables, if you want to use a remote backend, we're going to talk about the remote backend. So like just to make it clear here before we move on, the remote backend is like you specify that the Terraform state, that this state that we saw here, this state will be saved in a remote location because this is extremely sensitive file that we need to preserve securely, and it may contain sensitive information, so we need to save it securely. But also it contains we should have it every time, otherwise we will be creating new resources. So you can specify to Terraform like, okay, I'm going to save this state in a remote S3, and all my team can share this Terraform state. And when we work in a clean way that will be not destroying resources or creating one every time. The second configuration that you need to think about is the cloud provider one. And the cloud provider one, there are different aspects. So you need to understand how you authenticate, you or the one or the runner, the software that will be executing the provisioning on your behalf, how it will be authenticate, how it will authenticate into the cloud providers. Or maybe you even the pipelines, like if you run pipelines in tests and staging and production, you need to understand and to specify this. You have also some specific parameters related to the provider themselves. We have a section about providers later. We're going to talk about them. And also, this is in terms of the parameters, and also the versions. You can specify which version of the cloud provider you can use. So I can show it quickly here in Brainboard because, for example, here in the providers, this is the configuration file that you may use. Like, for example, here for AWS, I say the version of AWS that I will use is 3.66. So like I want to pin this version of AWS because I don't want to use the latest. Maybe there are changes that I'm not aware of, and I can pin it. And this is also the configuration of Terraform here in the block Terraform. This is where you can include also the configuration of Terraform. And the third part is the environment that will provision the infrastructure using Terraform. So I talked about it briefly in the provider. So yes, and this is important because like first you prepare everything, but the environment that will be executing and provisioning the infrastructure on your side needs to be secure as well, because this is part of your delivery workflow and delivery chain, and need to be secured and need to be reviewed. So these are the main part that you need to think about when you think about working with Terraform and using it as a provisioning tool. So now the hot topic is how files and folders are organized within Terraform. Like maybe you have seen some Git repos, and like some of them put use files, flat files in the root directory. Some of them use maybe folders. So you need to think about it beforehand. So maybe this is an advanced topic, but I just explain it that you will keep it in mind. This is part of the training that when you work with Terraform after this training, you will be able to understand at least the information that you need to think about. So the goal of the configuration should be clear. It only allows you to have structure that eases maintenance and readability. And maintenance, not just for you, but for all teams working on the infrastructure. And especially now that we are moving into cloud native infrastructures, which means cloud native infrastructure means the architecture of the application will be more or less the architecture of the cloud infrastructure. So this is a very important point. And keep that in mind when you think about the configuration, because you can overthink it, you can just skip it, but this is the goal, like to have maintenance and readability for the teams. So now within how the files within Terraform are organized, there are some obvious ones, like variables. You put them in variables.tf, outputs.tf, providers.tf, the main and the versions. There are others that are not obvious. For example, so you need to think about it like in the Terraform files. You need to think about it. Am I or my team or my organization, is it infrastructure logic, or application logic, and you organize your structure that way. If you are like just working on the infrastructure, so organize it in an infrastructure logic, like I want database.tf, compute.tf, network.tf, and so on. And if I'm not a more application logic, so I need to think about, okay, this is my backend, this is my front end, this is microservices one, this is microservices two, and so on, and you organize the information that way. And keep in mind that like working with the infrastructure is not just you, it's you, your colleagues, your developers, maybe project managers, everyone who will be working on like the infrastructure should be included on how you build infrastructure. So now in the configuration, and this is in terms of files. Now in terms of how folders are organized, or like more specifically how the environment are organized. So that like when you work with infrastructure, you will be having different environments. Maybe you just have one environment, production, and you don't care about the slide, like everything is in production. And maybe you will have more environments. So it's going to be maybe dev, staging, quality assurance, QA, testing, and so on. Anyway, you will be having environments, and you need to think about them. Like there are different strategies on how to do that. You either use Git branches. This is one of the like, yeah, the way you structure the infrastructure. I'm not recommending any, like, I'm not giving a recommendation. I'm just talking about the possibilities of how you can do it. So you may use Git branches, and you say, okay, I have Git, I have the main. The main represent the production. I have like another branch which is staging, another branch which is dev, another branch QA, and so on. You can also use Terraform workspaces. And now, like with Terraform, you can use the workspaces. Workspaces is just like folder wrapper about it. And there is an important point, like when you use Terraform workspaces, you can use Terraform cloud workspaces. Sometimes it's not easy to understand, but keep that in mind that you have this option. Or you may use them in separate folders, which means separate folders like I have a folder for development, development. I have a folder for staging. I have development for production, and so on. And if like to organize, the information this way, there are some consideration that you need to think about. And these questions, like I do not have answers for you for these questions. These questions that you need to ask yourself, your team, or your organization on how to work with it. And these are important because you either start working with Terraform with no strategy until like the reality hits you and you say, okay, my secrets are not managed, everything is leaking. Or you plan it before, at least you understand how it works. So the first point is you need to understand how to promote architectures from one environment into another, if you have one. Like for example, I work on architecture on development. I'm done. Everything is okay. How can I promote it into staging? This is very important information. Like either you copy paste, either you push the branch, either whatever the strategy. This is something to think about. Because the infrastructure should be considered in its entirety and not just provisioning. And this is like what we have seen when we start working with Terraform. Everyone is like, think about the provisioning only. I just create the infrastructure. And when you really start organizing things, you feel that, okay, provisioning is just the first step. This is the tip of the iceberg. You have a lot of things to think about to manage the infrastructure in a proper way. The second point is how to share and scope variables. And I put share and scope because this is two different topics. How to share, this is, for example, here in this diagram, I have a staging and production environment. So I need to understand if I need to use shared variables between all the environment, or I need to scope them. I need variables specific to development, variables specific to staging, or variables specific to production. So this is why I said you need to understand and to plan it beforehand. The other part, important one, is how to manage secrets. And like there are different strategies how to manage secrets. You can inject it in the pipeline. You can use Vault. You can use the credentials from KMS, cloud provider. There are different ways to do it. So this is something that you need to plan, and especially when you work with different environment. Like you do not want the same secret to be used in all environment. You need to only secrets to be used in dev, and specific ones in staging, and all the ones in production, and so on. The other part is how to manage cloud providers' credentials. Is like which strategy you're going to use to authenticate to the cloud provider, and this is a very important one because it depends on how your security work. But this is something that you need to plan beforehand, and this is like what I've seen is it's more a common strategy. Like we use only roles, we use only this strategy or another. The other point is how Terraform state files are managed, and especially when you have different environment. Do you like separate them in folders? Use remote backend. Remote backend should be shared between all environment or not. So this is very important information that you need to think about it. And the last point in terms of consideration is like you provide a cloud governance on how to use cloud infrastructure. Like who is authorized to do changes? Because when you work on Git, everyone cloning the code should be able to push into the repo. This is in case when you use repos, like when you have a merge strategy and you have gatekeepers and so on. So you need to think about it because, as I said, infrastructure as code is applying the code principles into the infrastructure. So this is a very important topic. Of course, there are more considerations than this. That like I just compiled a list that's a good starting point for all of us. And you can have maybe your internal policies like for any kind of specific environment that you have. So this is not limited to only these points. And I suggest now that we take a break and take some questions.
Thanks a lot, Shafiq. We have some questions from the audience. Can you hear me well?
Yes, I hear you very well, Tak.
Perfect. So I am going to read you some questions. So the first one, writing HCL code, are you bound to JSON or can you use YML?
YAML, yeah. You just use HCL at our stage. And like when the one who asked this question maybe is new to Terraform, don't think about JSON, just use HCL. This is the simplest answer that I can give. Later, when you get your hands on Terraform and you master it, go look for the JSON. But I personally have never seen anyone using JSON, Terraform JSON. So just use HCL.
Second question, why choose Terraform versus other infrastructure as code?
This is a good question. I would say this is like affinity, like what do you like? And there are like different points. The first one is affinity. What do you like to use? The second one is the learning curve. Like if you feel that you can understand and learn Terraform quickly and use it, so you go for it. And the other point is now like we know that an industry is moving toward infrastructure as code. And the dominant one from my point of view is Terraform. This is why, for example, at Brainboard, we took the decision to base Brainboard on Terraform. So Terraform generator. It's more the question for you. Now for the industry, I'm seeing that the industry is looking more for Terraform. And like for the personal level for your career, maybe mastering Terraform will open doors for you more than any other language. And for example, I was working on Ansible before, and I was like one of the fans of Ansible. I was even doing training on Ansible as well. And I realized that okay, Now we are moving more into the cloud and more into especially cloud native implementation and so on. Terraform is more getting more shares than the other infrastructure as code tools and languages. So yeah, this is like roughly some part of the decision. It's up to you, and the other one is the industry and the learning curve.
Then we have another question. Why would you use Terraform over Pulumi?
Again, this is like to me, this is not. There is no truth like you need to use Terraform or you need to use Pulumi. It's I saw both cases. For example, developers feel more at ease when they use Pulumi because they can integrate Pulumi into their code. Because Pulumi integrates into your code. If you write JavaScript or you write Python code or Golang, you will be able to write Pulumi in this language, the language of your preference, which means the learning curve is somehow low because you just need to learn just some basics on the resources for Pulumi. And the other hand, using Terraform is like I know that you need a learning curve to use it, but it's up to you and your affinity and also your learning curve. Maybe when you learn Terraform, it's going to be easier for you because you have a background that allows you to understand it easily. Or maybe when you learn Pulumi, you feel Pulumi is a good choice because I'm a developer and I can find it easy to work with it, and you can use it.
Then can you use Terraform for on-premise?
Sure, you can use Terraform for on-premise. I'm going to talk about it in the providers, not about this point specifically, but in the providers, there is a link that I share with you where you can see all the providers of Terraform. And I suppose when you talk about on-premise, you're either talking about VMware, maybe VMware, Nutanix, OpenStack, and so on. All these technologies has Terraform provider. So you can use it to manage on-prem as well.
Then we have another question. How could you test if the Terraform configure files create the required infrastructure?
How do you test if the Terraform the ultimate test is you go to your cloud provider and check the resources, if it really created the resources as you want it or not. And now the industry is more settled on Terraform. So the technology is approved. I don't think that even big companies are using Terraform. So, but if you want to check, you just go into the console and check the configuration.
How to upgrade the Terraform without affecting existing infrastructure?
Upgrading Terraform is always something we can say challenging. Sometimes it's not that hard. Sometimes you need to deal with it. But again, I go back into the slide that I showed here. Yes, you need to understand two things: the Terraform, the binary, and the cloud provider. So when you talk about updating Terraform, do you mean updating the binary, or you mean updating the version of the cloud provider? So I'm going to show it here in Brainboard. Here's some of the versions of the cloud provider, and I take advantage of this to show you something. I'm going to switch into new architecture because I think people are not able to see it as small. So yes, I take just an example to show you a resource. This is an instance in AWS. So
can you make your screen a little bit bigger for the audience? Is it possible?
Yes. Is it yes, I'm going to zoom a bit. Yes. So for example, this is the version 4.8. I do not have here mandatory information. And if I change the version into, for example, 3.3, and I open the configuration, I have mandatory information here. So it depends. This is what you want. This is in terms of the provider upgrade, or you want the version of the binary. So the version of the binary, you want from 1 0.0 or 0. Something and to upgrade into the latest one or not. So usually upgrading the binary, it's not problematic because there is like when you upgrade from 0.10 to 0.12, there are breaking changes that you need to think about them. But if you started working with Terraform prior to 0.12, it shouldn't be an issue for you. Now, updating the cloud provider, you need to understand what changed, what is deprecated or not. And this is like Terraform can help you on that because you do the init, a Terraform plan, and you can understand with the new version, and you can understand if there are something changed or not. And you can update it that way.
So we have other questions.
Let's take the last question to move on. And
yes. So I'm going to read. So what are the TF state? How do you say them well, and what are the best practice for the TF state?
Okay, the best practices in terms of the TF states. So this is a very good question. The TF states, the best practices is to use them to use a removed backend. This is definitely one of the best practices. And the removed backend, for example, if you use an S3, AWS S3, you need to use to enable encryption. So because it contains sensitive information, and to limit even within the organization who has access to what and why. The other point is when you use the state, like Terraform need to manage the lock-in around the state. Like when someone is using the state, another one shouldn't be allowed to do that. And this is a very important aspect. This is like you need to plan to think about it. And best practices is to use a lock-in mechanism. And one of the, if you use S3, you can use DynamoDB for the lock-in, or you can use now Console for the login. For the lock-in as sorry. So yeah, you need to think to put it on an encrypted backend and to manage the lock-in. This is like the 2 points that you need to think about when you use the state.
And one last question.
Yes.
How do I connect Terraform to my personal AWS account environment to provision some resources?
This is like you need to put, this is in the provider configuration. You need to put your credentials. For example, if you use AWS, use your credentials in your home repo, in your home directory, in your machine, like .aws, and you put the credentials inside it. And Terraform, it will look for these files for the credentials and use them to authenticate and go into your provision infrastructure into your cloud provider. Or also you can use them as an environment variables. This is, for example, what we do at Brainboard. We inject the credentials as an environment variables because we do not store anything, and we want them to be just used only at the execution time and not saved. So you have different mechanisms. So let's go now and see the resources. So if you have other questions, so write them down. The team will take them. And if we cannot answer all of them, we will reach out to you to give you the answer. So feel free to keep asking the questions, and we'll take them after. So now that we understand the configuration of Terraform, how it executes, how it runs, and so on, now we zoom on what we will be creating in the cloud infrastructure. So we will be provisioning what? So this is where the resources come in. So the resources are simply cloud infrastructure objects that have specific settings. This is what you want to do, what you want to provision, and Terraform will create this resource with a specific configuration. And usually the block for the resource is, like, as I said, is the resource, the name of the resource, the type, and especially the resources that belongs to cloud provider. You're going to see AWS, for example, underscore instance. If I use Azure here, instance for Azure, for example, you are going to see, you're going to see resource Azure RM underscore API underscore management, and the name of the resource. The name of the resource. And inside the resource are the information that you need to fill. These information are available here. For example, if I took this virtual machine, these are the information related to this virtual machine. These are the parameters that are accepted by the cloud provider. So I'm gonna, let's zoom a bit. We're gonna come back to this specific points later in the slides. So, and you have two categories. So you have resources that belongs to a cloud provider. This is what I told you, like the cloud provider underscore the name of the resource. I put the dot because this is how you can access it, and I'm gonna talk about it later. And there are resources that are called native resources. So for example, the native resources are resources like local file, DNS, and so on. These are specific to HashiCorp, and when you use them, you don't specify the AWS, you don't specify the provider before. You just use them. Like if I take here custom resource, if here I use a custom resource, I will show you. I will be able to add just the name. And by the way, I talked about the list of the providers. Here is the list of the providers. It's called browser providers. I give you the link here in the chat as well. So it allows you to if you want to use any provider, these are the major ones that are official, that called official with a badge official, all these ones. And what I said, like for example, if you want to use local files here, this is locally is provider. You can see here in the resources, it just uses local file. So there is no the name of the provider underscore. So this is in terms of the two categories, like random password, local file, DNS, HTTP, and so on. Now, we zoom on the provider because the provider will be providing the resources that we use. So the provider is a plugin. It's called in Terraform a plugin, and will be downloaded when you do Terraform init. So when you do Terraform init, Terraform will look at the providers that you have defined or used and pull them locally. You can find them in the folder.terraform, and it contains both the resources and the data sources. So we'll be back. We'll be talking about the data sources later. And now these providers have different versions. You can pin the version, like you say, okay, I want to use the version like 3.2 of Azure, or I want to use 2.78. And when you do that, like in the providers, it will be like you can pin it here. The provider, Azure RM, the version is this one. AWS, the version is this one. So you can specify the version or not. If you don't specify the version, Terraform assumes the latest one is used. So be careful of that. And if the namespace is not provided, it will be assumed to be HashiCorp. The namespace, maybe it's not now obvious to you, and maybe you have not seen before. Like I'm going to take custom resource to show you that. Like for example, here I'm going to use here local file. So, and like here, I'm going to say count equal 3. I add this code. So once I added, like this is the custom resource that I have added. And in the providers, I do not need to add anything because this is native one. So it doesn't have, the default namespace is HashiCorp. If for example, I use another resource, I'm going to duplicate this and use another resource. For example, the example that I gave, JFrog Artifactory. And by the way, we can check it here. like JFrog Artifactory here in the documentation, I can see that you need to configure JFrog/Artifactory, which is not the case, for example, for if I take, let's say, for example, if I take auth0, the provider, it's not specified here, but the provider, okay, I'm going to take, for example, Alibaba. So yeah, this is in the official namespace, but in all cases, if you use a provider, yes, let's say Aviatrix. I hope we have, yes, the source here, it's going to be Aviatrix system/Aviatrix, because the namespace is not the namespace of HashiCorp. So for example, if you want to use resources from this cloud provider, for example, you want to use, just copy this one. If you want to use, for example, Aviatrix firewall instance, this one. So first, like in the configuration, you can adjust, this is just to generate the code. And I'm gonna say this is Aviatrix instance here. That will be in the type. I give it any random name. And in the code, I'm gonna put this code here and save it. So once it's saved, I don't know if my network is lagging. Okay, so this is Aviatrix here, the configuration, but the most important thing is in the providers, it will be added the source this way. In the required providers, like you need to have Aviatrix with the source, and you specify the source to be like for Terraform to be able to pull it. This is like some of the errors that I've seen, like you have problems and you don't realize that the problem is the workspace. And when you dig inside, when you dig deeper, you understand that it's a problem with the workspace. Cloud providers support aliases. Like if you want to have specific configuration, for example, here, yes, for example, for AWS, we use aliases like alias to use multi-regions, to be able to use multi-regions in AWS, for example, in the same architecture. You can use alias, and inside the resource, for example, here for this resource, when I choose like region Hong Kong, and I save it, it's gonna be here in the, yes, it's gonna be added the provider with the name of the region. And yeah, the last point is the block required providers. So this is what I showed you here in the providers.tf. This block, you can define all the required providers. And this is, by the way, the configuration of Terraform. Inside, you can define all what are required. So, and Terraform understands that before doing any action, it needs to pull these specific providers with specific versions before doing any action. So this is in terms of the provider. Now let's zoom on the anatomy of the resource and how it works. So the resources, like the resource, have different element. So it has a type, and this type, if it's, as I told you before, if it's the cloud provider, it's gonna be the cloud provider and their score. For example, when you hover here, I can see when you open here, the resources is, for example, this one, Azure RM app services, and so on. Maybe it took another, yeah, the architecture that I cloned here. So yes, here are the resources. So this is the name, the type of the resource. This is AWS auto-scaling policy and so on. This is what you can find in documentation. And every resource contains, I'm going to zoom here that we'll be able to see. Every resource contains information. Information inside it. This is called cloud information. This is what you should be configuring. And this is when you write the Terraform code, this is like the block what you write. And these are the parameters that are accepted by the cloud provider. This is only the cloud provider information. So you say, okay, the capacity is this size. All the information that you find here, you can play with them. So, and information about the parameters you configure, you find them at the documentation of the cloud provider. For example, if I go to AWS here and I go to the documentation, I will be able to see, for example, for the API gateway, if I want to use this resource, here are the parameters that I need to fill, and so on. And now this is like the cloud information. This is all what comes from the cloud provider. It has meta arguments. The meta arguments are the arguments that are specific to Terraform and how Terraform, like the capabilities that Terraform gives you to use maybe loops and so on. We're going to see the meta arguments, but just to show you, for example, how it looks like, it's here. It's extra attributes. Yes. Like the count that depends on the for each, and we're going to see them. If you want to create like multiple instances of the same application, of the same resource, or if you want to loop over a map of key value information to use them, you can define it. So these are called meta arguments, and you can use it. You have also post-deployment. This is called provisioners in Terraform, which means once the instance is created, you will be doing some other actions. Like, for example, maybe call remote, like maybe, call execute a command locally, like delete some files, add some files, notify something. You can, you have provisioners. And you have the list of the provisioners in Terraform. We're going to talk about it later. The other part is, this is the post-deployment. The other part is the actions that are that Terraform does on the resources. So there are like 4 actions that we talked about before. So the resource will be created or destroyed or updated, or in cases that Terraform cannot change in place the information of the resource and update it, it will destroy and recreate the resource. And these resources have attributes. And this is a very interesting and very important point. Like these attributes allows you to use them into different into other resources. Like you want to use, I give you an example here, like in the design, I want to use for example, I see the security group here, and this security group, or maybe I'm going to create a new, go back to the architecture one that I had, and I choose AWS, and for example, I'm going to choose subnet here. And I put the instance inside. So here, for example, this information is handled by Brainboard automatically, but just to show you, for example, this is the configuration of the instance, and I told the instance that the subnet ID is the subnet called subnet4 that I just added .id. And this exported attribute, I can find it here in the information of this resource here. So it could be the ID, it could be the RN, it could be any other information. Like if I choose this resource from Azure, the exported attribute should be different. All these are exported attributes, and I can use them. I can use this information in other resources. So this is in terms of like this is anatomy of resources. I know sometimes like there are a lot of information about this resource, but this is like the core principle of Terraform. You need to understand how it works, because like all what you will be doing is creating resources or destroying resources or updating resources. So and now we go back, we zoom also on like what happens inside the resources. So the resources are like, in terms of execution, Terraform can do parallel execution of the resources. And you have an option in the apply to specify how much resources will be created in parallel. And once that's why it's really important to understand the dependency, because if you do parallel execution, and for example, you need one resource to be created before another resource, you need to specify this dependency. Like to say that I want this resource to be dependent on the other one, which means I want, before creating the first resource, I should create before creating the second resource, I should create the first one. And once it's created, I go ahead and create the second one. And as I said, the exported attribute, as I talked about the exported attribute here and how to use them, this is what I showed you, or I can take it out, for example, this resource here, and I can say, okay, now in the subnet field, yes, subnet 4, I use one of the exported attribute, for example, the ID. And I have it here. So how to use this exported attribute? You need to write AWS subnet. This is the type. Then the name of the resource. Then the ID. And just to show you, for example, here, I changed this name. I'm going to call it, for example, training. And I save it. This is the resource name. Now, if I go into the subnet, it has been changed, training, but I can specify, I can say, okay, subnet, I'm going to use the subnet training.id, and I'm going to save it. So this is how you use information inside resources from other resources. And in the Terraform code generated, like in my instance, which is here in the subnet ID, this is exactly what I told you. I use the resource dot the name dot the exported attribute. And the third point is the meta arguments. So the meta arguments, this is what I said, it allows you to either organize the dependency, for example, now I want this resource to depend on the subnet. So for example, here I'm gonna write the subnet. If the subnet doesn't exist, the resource will not be created. So the creation of this resource will wait until the subnet is created before it will be created. So here you have it here. The subnet it depends on the instance depends on the subnet. And you have also other parameters for looping. Like for example, I want to create let's say 5 instances of this resource. So there are 2 ways to do looping. The first one is the count. The second one is for each, and you need to understand when to use what. So the count, to use the count is like an array, which means it is ordered. You have the index of the elements inside the array starting by 0, and you can here, for example, you can once you do the count, once you use the count, you have you can use this information, the count dot index, to be able to as a variable, and you can use it in the names. Like for example here, in the name I can say, for example, let's just, for the AMI, I'm going to use AMI 1 and use the count dot index, and which means that for every instance that will be created, the AMI will contains AMI-1, then 0, 1, 2, 3, 4, and 4, because it starts from 0. So this is the first way to use the loops. The second way to use the loops is the for each, for example here. And the for each needs to be you need to provide key value. I can say here for the for each, I can say, for example, here, I can open the editor here, and I can say, okay, instance one equal for example, instance 1, instance 2 equal instance 2. That's right, and I save it. Once I do the for each here, I have, as it told like here, once I use the for each, now I have the each keyword that I will be able to use in the parameters. So for example, here, I can say now, instead of the AMI given using the count, I can now use, for example, each dot, for example, key or value. So I can either use key or value as an information, as a variable everywhere in the configuration. So, and once I save it, it will be used that way. So the main difference between both of them is like if you want to organize, if the resources that you create have like an iterative parameters that you can use. You use counts like in the AMI or maybe in the instance name, instance 1, 2, 3, it's incremental. You just use the count. Or like VS, when you will use for each is if you have specific values that you want to, like the specific keys with the specific values, you can this way use for each, and like it's up to you on what makes sense. The other information is the provider and the life cycle. The provider I showed you here, like you can, as I told you, can use the provider and the alias and information from that provider. And like this is what you have defined. You need to define it first. Like you said, the provider and the name of the provider, and you put information inside to configure them. Then you can use it inside the resources. So like for example, here in the provider name, in the provider parameter, I say this is AWS with this alias. The other meta argument is the life cycle of the resources, and you can specify it here. Like for example, you can say create before destroy. Like before, if I have updates to do to the infrastructure or to the resource, please create before destroy the new, create a new one before destroying the old one, and so on. So, or prevent destroy, that the resource will not be destroyed, or ignore changes if you have changes to ignore. So this is in terms of the meta arguments. I see that it's already 7:30. 7:30. Okay, I hope that we'll go till the end of the training. Otherwise, we will be definitely organizing another training, and we'll be organizing a Zoom on different aspects. Maybe a Zoom on how to build modules, and a Zoom on how to use data sources, how to use functions, and how to use different aspects. This is what we have planned, but now it's obvious that it takes more time than planned, and we go through that. The most important information now is regarding the resources is the data sources. Data sources are like specific type of resources. So the resources are the cloud resources that you will create. In what Terraform calls resources are the resources that Terraform will create or update or destroy. The data sources are the information that are defined outside of Terraform that you can bring into your code and use them at the execution time. For example, if you have, I show you that. For example, here, instead of using this subnet that will be created from scratch, I'm going to use here, like, for example, data sources, and I'm going to use subnet that I already have. I just drag and drop here, and this is information of the subnet. And I will put here in the ID, the subnet ID. And Terraform will understand that the ID, for example, I'm going to put here random ID. drag and drop the resource to show you how it works. Yes, this here is instance, and in the subnet it used the data subnet, data AWS subnet, the name of the subnet and the ID. This is what I told you, like the exported attribute from the resources. So when you import them, which means that Terraform will not create this subnet, but use an existing subnet with the ID that I provided here, and put this newly created instance inside it. So this is really helpful, especially if you have like policy or shared teams. One of the teams manage the network, the other team manage the databases, or other teams manage security and so on. And like you can use existing VPCs or existing resource group if you are an Azure user, and you can use all this kind of data and not create them with newly created resources. And these data sources can be local actions. This is very important one, because we usually think about data sources are only information that are defined outside of Terraform, which is true and sometimes not true, because you can do local actions in data sources. This is, for example, the case for local file. For example, you want to read from a local file and use it during the execution to, for example, populate IAM policies or whatever calculation that you want to. So, and you can you can check the list of the local actions that you can do in Terraform and use them. And data sources support dependencies as well, because they are resources. So you can, for example, one of the dependencies here, for example, I can say this virtual machine depends on the subnet, which means before creating the virtual machine, you need to pull all the information about the subnet and then put this virtual machine and then create this virtual machine inside the subnet. So it supports dependencies. Actually, Terraform support like what they call implicit dependency management. So for example, when Terraform detects that a resource is used in another resource, this is implicit dependency, which means before creating this resource, I will definitely do this one. But you can define explicit dependencies with the depends on parameter. And the data sources support the depends on, and also support the meta argument. They have the meta argument here. You can use them exactly the same way that you use the resources. And these data sources are pretty simple. They are like just to fetch information outside of Terraform. So just the same logic of the resources applies to them. And now let's take a break and take questions. I think there are a lot of questions.
Yes. Okay. So the first question: Can you please explain state file locking?
State file locking. Yes, the state file locking means, like as the name explains it, like I want to lock the state and to be able the only one doing modification to this state, which means like I have the truth. I want this truth to be in the locking. This kind of locking happens when you have parallel executions. For example, you have the same, like for example, you have the remote backend on S3, and there are two parallel executions on the same Terraform state, because, for example, you and your colleague are modifying the infrastructure at the same time. Maybe you don't know with each other. So you need to lock it. Like now I'm working on it, I lock it. When I finish, I unlock it, that the other ones can put their truth on top of the same truth that I have.
Another one: what is external data block in Terraform?
External data block?
Block in Terraform, yes.
External data block in Terraform? I don't know what does that mean, but external, like everything external to Terraform means everything not managed or not defined in Terraform. And for example, data, yes, the data is an external data block. This data resources is information that are defined outside of Terraform that you will fetch them at the execution time and use them.
Another question, can you please explain TF file a little bit more? Maybe with an example on Brainboard.
The TF file, little more. Okay.
Can you show and can you speak about the TF file a little bit more?
Yes. Okay. So the Terraform files. So just I want to have the colors here of my editor. I switch into the code view. So the TF files, yes, here are my colors. The TF files is the file that contains the which is called the configuration, which means the definition of the resources that you want to create. And so maybe the one who asked this question maybe missed the beginning of the presentation. Just go back into the slides to be able to. Yes. So you have here like the TF files. You have a blocks that contains it contains blocks that contain definition of the resources, and all TF files are like that. Whatever the number of files you have in the directory, they will be all combined in one document, and this giant document will contains all the definition of the resources. Like if you have a resource or data, or maybe variables, defined variables, or maybe providers, definition of providers, or whatever you have in Terraform files, that they will be all combined in one Terraform file. And this is it. Like in Terraform will read this file, understand that these are the resources to be updated or destroyed or created, and it will create them.
Another question, is it possible to perform multiple operations in same state file without any conflicts or errors?
Performing multiple operations, what does that mean, operations? Like, we need to understand what's the definition of operation that this person means. But does it mean the external, the provisioners? So the provisioner is defined at the resource level. So you can define as many provisioners as you want on the resource level, or maybe like some calculation through the data sources. The answer is yes. So we need to understand what actions.
Yes. And another one, what will be the general architecture in AWS DevOps project?
I don't understand this question. Can you repeat it, please?
Yes. What will be the general architecture in AWS DevOps project?
I don't know. Maybe, I don't know if they're asking about Brainboard or in general.
Can you show, for example, architectures that we have on Brainboard, the main one, or even the templates?
Yeah, these are like architectures that we have in Brainboard. Like, this is not the point of the training, but you can check them in the templates and clone them from the templates and use them. But I don't think this question is related to the Terraform itself and the training itself. But the one who was the question, if he or she wants to check the architectures on Brainboard, so feel free, or reach out to us. We can help you.
And there are no more questions.
Okay, perfect. So we can move on, at least to talk about the modules and the variables. And at least we finish this one before crossing the 2 hours. So yes, now we move into the modules. So the modules, simply put, are just containers of resources. So as I told you, like you will be always working on modules, and like the root module is always there, and you can define what Terraform calls child modules. They can be local or remote, and which contains resources. Like, the purpose of having a module is like you have a building blocks. Like, for example, you have some specific configuration of a VPC or subnet or an RDS database or whatever, and this specific configuration will be used all the times in the same way. You can convert it into a module and use it later, instead of every time redefining the complete resources inside it. For example, yes, we can here, for example, look for Terraform VPC module. This is a VPC module. Yes, this is the VPC module. We can go inside. This is just to show you how the module is combined. It's just resources. I will import it in Brainboard and show you, like, in the diagram, how it looks like. So here, VPC import, just to show you the face of the modules. You either, if you use Terraform, you'll be, I think, using modules either from the community, or maybe the one defined by your colleagues. So yeah, this is a huge one. This is the VPC module that you see here. So this is the module that you will be using with just source here. You can import it, and this is all the components inside this module. So this is, simply put, the modules. And because and to use them, you just need to define, like, let me go back into my initial architecture, this one. And I take the source of this module. Now, to be able to use this module, I just define a block module with a name and give it a configuration. Inside this configuration, there is one mandatory argument, which is the source of the module. You can put versions or not. And like, as the module encapsulate all the resources inside, and when you import a module, it's just like any other resource. You cannot access the resources inside it. You need to define output, and these outputs are the output that are exposed from the different resources that want this module to export. And like, I show you a clear example. For example, here I can import a module. I can give it like a name, AWS import, or AWS VPC import. I can specify the version or not, as I told you, and I import it. So this is like, I have this module, and I show you, yes, here is the definition. Here are the parameters of the module. And like, as I said, the source, you have the source, and you have the extra attribute, and here are the outputs. So these, all the outputs that are defined in this module that I will be able to use. Even if in the documentation here, if you go into the outputs, there are 109 output. All these output like are outputted from this module, and I will be able to use. And yeah, when I apply, for example, here, I just this is the definition of the module. It's like any other resource. You have the module, the name, and the configuration. The source is mandatory, and you can define any kind of parameters inside the modules. These parameters are called variables. These variables are what are defined in the modules as input. What do you see here? Input. This is what, for example, here in my example in Brainboard. So here is all the variables that I can either add, modify, or define in this module. So when you build a module, you can define a set of variables. Like when I go back now into, I imported this VPC module. Yes, here are the variables that comes with it. So we have 169 variables. So like, here are all the variables that have been defined within the modules. So this is roughly the modules. We will be doing a session zooming on how to build modules. So stay tuned. We'll share it on LinkedIn and hold the next time. We'll do everything clean and start on time. So don't miss it. Maybe is there any question, Tarek, about the modules?
Yes. Is it usual to have Terraform registry modules and importing them into a project?
Yes, this is a common. This is like the way modules work. It's better that you put them into a registry because yeah, you have two ways to use modules. You can locally you define them locally, which means within the project within which you are working, and you use them with dot slash the name modules and the name of the module. But as best practice is to put them into a registry, either public or private, and there are different type of registries: Git, S3. This, for example, here, this is the registry of Terraform. This is the public one, registry.terraform.io. And when you put the source here, so Terraform will pull the source module from the public registry. If you specify Git, it will get it from Git. If you specify S3, it will get it from S3.
Another one. Any lights on Terraform role in cloud landing zone in GCP? If possible, if it's possible, kindly share links for more details.
I suggest for the one who asks question that we reach out to us and we can like sit down and explain what it really means the landing zone and the relation of the landing zone with the modules and the registry. But like if you have a landing zone that contains GCP landing zone that contains module, like you can use them from the like either from defined in the registry, public registry, or in your own registry. You can use them. And yeah, so like reach out to us if you have any specific questions.
And we're good. There are no more questions.
Okay, so I think we can do the last section about the input and output. Yeah, here we go. Input and output. So the input is simply like means variables in more global, broad way. Variables and locals. So locals are usually used in modules, and variables are used in every aspect. And I personally advise you to use variables as much as possible because it allows you to create repeatable either templates or repeatable and make it extremely flexible, the working with the infrastructure. For example, and the definition of the variable is going to be like, for example, here, yes, I go into the code and I show you this repo that I imported. I go into the variables here. Yeah, we have 100. Yes, here is the definition of the variable. So you have the variable. This is a keyword, the name of the variable, and its definition, its description. Usually you have, so in terms of description, so for the default arguments, you have the one that I showed, either default, either the type. The type can be like either string, number, boolean. This is like what they are called simple types, or more complex one like lists, sets, maps, and objects and tuples. You can add a description into the variable. Sorry, here. You can add description into the variable. You can have a validation. The validation is a function to validate that the variable is exactly what you want. So this is really helpful if you want to validate your variables, maybe the way how variables work or the expected value or whatever you want to validate. It can be sensitive information, like, yeah, you can flag it sensitive. And when you flag a variable sensitive, Terraform will hide it from the output, because one of the hottest topics in security in Terraform is the logs. Because when you do the execution, you will be having in the logs, if you didn't flag variables, you'll be having clear password, clear sensitive information. So that's why in all cases, these information will be clear text in the state. So that's why you need to protect the state in an encrypted backend. But yeah, keep in mind that if you have a variable that is sensitive, think about putting it sensitive true, and Terraform will hide it from the output. And the last one is nullable. And these, there is difference between the variables that you define. So you define at the execution and their values. So this is what I put here. Sorry. Yes, this is, maybe I refresh again. Yes, variables .tf vs variables .tf vars. TF vars are the values of the variable. This is how a naming convention within Terraform. If you put TF vars, means the values of your variables. So what in terms of best practices, you can define any kind of variable in tf.var. You can give it a default value. So let me show you like in Brainboard here. Yes. So here's the variables. You can define any kind of variable, give it a default value, and keep the value empty. You don't give a value. If it's a sensitive information, or maybe regarding if it's sensitive or not, maybe this value is specific to every environment. So you can inject the values of the variables at the execution time, or you can like either put them in special TF vars or inject them as environment variables, or whatever the way you inject it. So there is distinction between the values, the definition of the variables and the values. Like when you define a variable, it's just a container of an information that will be used. The value is another story. It could be sensitive or not. It could be specific to an environment or not. And you need to treat them separately. And as a best practice, do not commit into your repo the TF vars, because it is specific to every environment. It may contain sensitive information. So keep it separate. This is like, yeah, the values can be defined in the CLIs. Do we have any questions, Tark?
I think for now there is only one more. It's what's the difference between child module and root module?
Shared module, yeah. The root, yeah, the root module is like the module number 0. The default one, if you don't define any module, you will be working at the root module. This is how Terraform works. Terraform only knows modules. So if you do not define any module, it will be you will be working on root module. For example, here, this code is the root, is like the root module. All this code is the root module. The shared module, what I call it shared, is something, is a module which is published on the registry, whatever the registry, public or private, that everyone can use. That you can use it by specifying the module block and specifying the source.
And there is only one more question, and I think after that is good. What's the significance of variables.tf, providers.tf?
Yeah, maybe, yeah, the one who asked this question maybe was referring to the files that we have in Brainboard. This is just in convention internal, like in Brainboard, to the variables contains that the variables that you define and use inside the resources. So all these variables, like here, for example, inside the resources, if I open any resource, I will be able to use, for example, here, var dot, I have all the list of the variables. I can choose that one and use it. So this is the variables.tf are, you can use them inside the resources. And you are right, the providers.tf contains information that can be used as variables, but are specific to the provider. Like it's not a general variables.
And I think we were good. There is only one more question. is there a way to use built-in functions inside variable block?
Yes, this is like what I wanted to show about the functions. Like, yeah, we had a section about functions and use cases. And I think it's better that we schedule another one. It's almost 2 hours, and like we zoom on them. I know that we have provided a lot of information, but yes, you can use function as the functions like Terraform functions are here just to show you where you can find them. Terraform functions are here, and you can, these are all the functions, like string functions, you can like use any kind of function, and you can use like instead of variable function or combine function and variables, you can do any kind of combination.
And I think we are good for today.
Okay, perfect. So yeah, thanks a lot for attending today, and sorry again for the small technical problem that we had at the beginning. So we have a Slack channel. Here is the link. If you can, yeah, you shared the link, Tarek.
Yes.
So feel free to join us if you want to learn about cloud, Terraform, and like any kind of learning you are into. And also you can ask us questions in real time, and we can help you. And yeah, this is our goal, is to help the community and share the knowledge with the community, and we will be happy to help in any way we can. So again, thanks a lot, and see you in another session.